Hi, it's Andrew Bayko here from ExamPro. Today is April 16th, 2019, and boy do we have a fun talk for you here today. We're going to be showing you how to run your own modded Minecraft server on AWS. And I want to point out, this isn't your regular vanilla Minecraft server. We're going to be adding some considerable complexity to the setup by including some game-enhancing mods. It does make the setup process more complicated, but in the end it really makes for a more enjoyable play experience. At ExamPro, we actually run our own employee server using this configuration, and it's a great way for our team to blow off steam while still technically being related to AWS. Now, even though this talk is about Minecraft, it's actually a resource that will help you study for the 3 AWS Associate certifications at the same time, as you're going to be getting some practical knowledge here on how to use a number of these AWS services. Over to our first meaty slide here today, and this is the architectural view of what we're going to be looking at today. So when we're building out a modded server, one of the first things we're going to need is a mod loader and also the mod pack, which is really just some files our server needs to load our specific mods. For Minecraft, there's already a great mod loader program available in the form of Forge. With this, it's going to be super easy for us to build up our mod pack inside of Forge. Then we can take this along with some other files and get it all pushed into an S3 bucket within AWS. The next thing we'll do is we're going to spin up an EC2 instance in AWS, which is going to be running the server itself. This will pull in all the files it needs from S3 in order to spin up and get everything installed we need. Once this is up and running, we should then be able to connect back into our game server using the Twitch client and start playing on our modded server with all our friends. A few other things we're going to touch on briefly today are CloudWatch events, logs, metrics, alarms, also the AWS Systems Manager, AMI, and Elastic IP addresses. These are not necessarily the focus of this talk today, but you should get to see some basic utilization, at least when we are building out this server. So without any more delay, let's get moving on to our first step. And for that, let's go ahead and get a new bucket created in S3 for our data. For those that are not already familiar with it, S3 is the simple storage service on AWS. You can think of it as a sort of giant hard drive space in the cloud where we can store all our files and other data without really needing to worry about the underlying file system infrastructure or other things we would on a typical network storage medium. Anything we put in S3 is treated like an object, and we can access it, modify it, delete it, or even publish it out to the internet with very little effort. When we talk about buckets inside of S3, it's really just a fancy name for root folders where we can set different levels of access permissions and other things particular to that set of files. So the first thing we're asked for when creating a new bucket is the name. Now, this name actually needs to be unique in the same way that an email address or a domain name would be. Today I'm going to call our bucket Minecraft-server, but if you're following along here, you'll need to set this to something else unique of your own choosing. If you don't, then S3 will just spit back an error letting you know that the bucket name is already in use and you'll have to modify it before continuing. There are some other initial options we can set on a new bucket, but for the sake of speed today, let's just go with a unique name and save it. With that bucket now created, the next thing we want to do is create a folder inside of our bucket. We'll just call this one Setup, as it's going to be where we place all our files that the server needs to configure itself. The first file our server will need for this is the Forge installer. This is actually available for free as a download on the Minecraft Forge website. Now, the specific version we select is really quite important. If you're unsure what to use, don't worry. In a later slide, we'll briefly explain how you can determine the correct versions, and you can even come back to this step later. Let's now jump over to the Twitch client, which we briefly mentioned earlier. This is what's going to let us build out our custom mod package that we need to load on the AWS server. If you go over to twitch.tv/downloads, you can download and install the correct Twitch client for your operating system if you don't have it already. Inside the program itself now, what we want to do is create a custom profile under the Mods tab. We'll give our profile a name. In this case, I'm just going to call ours Minecraft Server. Then we're going to select for which version of Minecraft this profile is going to be for. Today, we'll go with 1.12.2. And the last thing here the profile asks for is the mod loader version. Now, if you remember our previous slide,
The version we select here just needs to match exactly with whatever we've downloaded from Forge and uploaded to our S3 bucket setup folder. With our custom profile now created, we can get started on building our mod pack. Inside of our profile, there are actually two options for adding the new mods, either the Get Mods button or the Get More Content button, which are essentially the same thing. If we click one of these buttons, we can then do a search on all the available mods on Twitch. And when we find one we want, we just select the install option, and this will add it to our custom profile. Today we're going to go with the Journey Map mod, which actually just adds a nice little overview map into the game that isn't part of the standard experience. Now, depending on what mods you select here and the number that you're trying to install, it's very possible some of these may conflict with each other and cause it to break the game. So in this case, Twitch actually gives us a great option to load up the standard game with our mods, so we can quickly test to make sure everything is loading up okay and working before we proceed. You may need to do this a few times until you have a working local version of the game that includes all your mods without any conflicts. So if we launch up our local game, there are a few things to take note of here. The first being this great little memory utilization bar. It shows us when it's loading up the game. This is going to give us a rough idea of how much memory we'll have to give our server when we're ready to stand it up inside of AWS. If you're doing a regular vanilla server, this isn't going to be a lot, but as we start adding more and more mods, you'll see this memory requirement is going to grow drastically. At the moment, you'll see the total memory allocated here is around 3 gigabytes just to start the game up. So this will help us to determine what sort of EC2 instance we need to utilize in AWS for our server. The other thing we obviously just need to check here is that the game loads up okay without crashing, and also that it's showing all of our mods loaded correctly. Here you can see our journey maps showing up in our top corner that wouldn't normally be there in the standard game. So now that we have our mods installed and we've confirmed we can load them all up locally without any conflicts, the next thing we need to do is build our mod pack for the server. To do this, it's just as simple as selecting the option in Twitch for Open Folder. This is going to show us our entire custom profile folder from which we only really need to take the mods directory here, and we can zip this up. This is going to be what our server needs to actually load the mods. The next step is just to take this mod zip file and we're going to upload this into our S3 bucket setup folder. So we now have our mod loader and our mod pack inside of our bucket. There's just one more setup component we're missing now, and that is a script that's going to run our Minecraft service on the EC2 server. You'll see the script is really only a few lines here. We're naming a service, and then we're providing the path to start up the mod loader jar file that we uploaded to S3 earlier. One thing to note here again is just that the mod loader version, this still needs to match up exactly with what we used in our other earlier steps. So you can write this information down in a file somewhere, name it as minecraft.service, then just take it and upload it to the S3 bucket setup folder along with the other two files that are already there. So with our mod components now done and out of the way, we can start looking at the EC2 side of things. And to start that off, we're actually going to look at the IAM, or the Identity and Access Management Console. In using this, we need to grant permissions for the EC2 instance to access that S3 bucket we created earlier. So to do this, we're just going to create a new permissions policy and also a new role, and then we're going to assign that to our EC2 instance. And now looking at the new policy details we want to create, it's again fairly simple. We just need to specify here that it's an allow policy related to the resource we created, which was our Minecraft server S3 bucket. Then we also need to tell it what access permissions the policy should grant. In this case, we want the access to list files in the bucket, get files, create files, and also the ability to change or delete files in the bucket if we need to. On the next step, we just have to give our new policy a name here, and then also we get this really handy summary at the bottom, which just shows us specifically what permissions the system's going to grant based on our policy file we just created. We can go ahead and save that. Then remaining in the IAM console still, we need to create a new role. When we do that, the very first thing we'll be asked here is to select the type of entity that the role applies to, and then also the specific service that it's related to. So in our case today, the role is for an AWS service, and the specific service we want is EC2. On the next step, we're asked to attach a policy to our role. If we do a quick search for the policy we just created, we can select the checkbox for our policy to add it in, and then just save and move on to the next step. Here we'll just give our new role a name, put in a brief description explaining what the role should be accomplishing. Then we'll just quickly review the other settings to make sure only the specific entity and policies we want are applied before we click Create. We now have our permissions policy and role along with our mod files, so we can finally get started now with spinning up our server itself in EC2, or also known as the Elastic Compute Cloud. This has all the tools we need to build a really highly customizable server. For people who are already used to using Heroku or DigitalOcean, this is essentially the AWS equivalent for that for running your application servers. So in the EC2 console now, we can select the option here for launching a new EC2 instance. And the first thing that we're asked is to select our desired AMI or Amazon machine image. Now, this can be a bit overwhelming initially as you start looking through the large multitude of different options that are available, but it's really just a bunch of baked machine images that have particular sets of software already preloaded on them for your convenience. Selecting the correct image is key, just because it's going to drastically limit the amount of configuration you need to do yourself personally. No matter your requirements, you can find a ton of Windows Server images, Ubuntu images, CentOS images, and a plethora of other OS versions, but for our purposes today, we're going to go with the Amazon Linux 2 image, not just because we love all things AWS specific, but Amazon actually have amazing support for all their own AMIs they develop internally, and we're going to go with Amazon Linux 2 over 1, just because 2 is the newest version, and that supports all the latest and greatest EC2 features. With our image selected, we now move on to choosing our instance type. If you remember from earlier when we were testing out our mods, we needed around 3 gigabytes of total memory. So in this case, we can go ahead and select a T2 medium instance, which should be more than enough power to operate the service. You could probably get away with running just a T2 small instance to save some money, but we're actually going to show you some easy tricks anyway that we can use to bring down our costs afterwards by using spot pricing and also only running the server at times we actually play on it. So going off the instance cost then, we could do some basic calculations to get an idea roughly how much it's going to cost. And knowing there's around 730 hours in a month, if this thing's running around the clock every day at 0.04 cents an hour, it's going to come in around $34 USD per month. The next thing we need to make sure of is just when we're asked what IAM role to assign the EC2 instance, that we select the specific role we created earlier in the previous steps. This is just going to allow it that S3 bucket access. Now we're going to look at building out our user data script. This is essentially just a regular old bash file. It's going to walk through all the installation and configuration steps we need to get our server up and ready to go. So if we look at the steps here, we're really just first installing Java, then we're creating a folder to put our Minecraft related files in. We download our mod loader jar file out of S3. Then we install that jar file, and after that's done, we download our mod pack files, unzip that to a mods folder in our Minecraft server directory. Then finally, we just download our Minecraft service file, also from S3, and tell the server to start up that service. This should really be everything our server needs to do from its initial startup to being play ready for us to log on. So once we've worked out all the steps necessary to start up our server, then all we need to do is make it so EC2 will physically run this when the server starts up. To do this, all we need to do is copy paste it under the user data section of the advanced configuration options. Anything we put in here will be executed automatically when the server boots up. Next, we need to configure our security group settings for the instance. This is going to be what it makes possible for ourselves and other people to access and play on the server. So going through our list here, the first thing we really want is SSH access, just in case we need to log on and debug anything. However, as it is a public server, we're going to limit SSH access to only our specific IP address, so it's not open to the wide internet. On the other side, we actually do want people to be able to play who are on the internet, so we're going to specifically open up the ports needed by the Minecraft client to permit people who want to play access. For Minecraft specifically, it should be TCP and UDP port 25565, and these should really be the only ports we ever really need to access on this server. All that's really left to do now is launch our server. This might take a few moments to start up, but once it's running, we should see we have 2 successful status checks, and we also see a public IP address listed here for our instance. This is what we're going to use to connect into the game server itself from Minecraft.
So with that IP now, we can jump back over to the Twitch client again and launch up our Minecraft profile. And this time we can go to the option for connect to an online server, and then we can just paste in our IP address along with our port number as our server address and click done. Straight away we should see we have an available server now in the list, currently at 0 players because it's only just started up. So the moment of truth, we can now click join server, and with a little luck you should now be standing inside your own modded Minecraft server that's hosted on AWS. Hooray! So technically we could just leave it like this even and start playing now, but as promised earlier, let's just look at a few quick ways how we can bring down our monthly bill a bit. And the first trick we have to mention is the AWS spot pricing I briefly mentioned earlier. The prices can vary region to region, but you can potentially save anywhere up to 90% of the total cost month by month. Now, the big downside with spot pricing is that your server can have occasional interruptions to the service. This means at any given time it could potentially go down for a few minutes, but if you're only building a server for you and your friends or your family to play on, this is likely not that big of an issue for you. In our experience, the spot pricing is never quite as high as 90% off, but just as a quick calculation, if you were to get the 90% off, this would bring your monthly cost down to only around $3.50 a month, going on the price from earlier. Dealing with occasional interruptions on the service, but as a trade-off for that cost reduction, can definitely be worth it. I'll quickly show you here some of the potential cost reductions you can get with spot pricing. You'll notice right away none of these costs are actually as high as 90% at the moment, but even with 70% off, say, that is still a massive reduction in your overhead costs. You could really see how economical it can get running an AWS server if you're prepared to deal with those occasional interruptions.
Back over to our architectural view of our server today, and to review, we have now built and packaged our mod pack using the Twitch client. We pushed that package along with the mod loader and service file into an S3 bucket. We then set up a custom IAM policy and role to grant EC2 access on that bucket. We created a new EC2 instance using a pre-baked Amazon machine image. And finally, we launched that EC2 instance, then connected into our running Minecraft server using Twitch again. Now, we have a few other services mentioned here around the side. We just didn't have time to get into too much detail today, so let's quickly run through some of these things you can do with your new server now as a next step to build out and really expand on your AWS knowledge so far. So, other cool things we can do with our server. And we actually do most of these things on the ExamPro Minecraft server environment. First thing is we can create a static website in S3. With this, we could have a page for people to go and get information about the server, or we could even expand on this idea using AWS Cognito and have them actually request access to the server from the page based on their Minecraft username. Scheduled backups with CloudWatch events. Definitely something you'll want to consider to always ensure a copy of your game world saved in the event something crashes. These can easily be set up to run at regular intervals on a schedule, and it's especially important if you're going to be doing the spot pricing model where the server is going to be interrupted occasionally. Another thing to do based around saving some money is actually shutting down the server when it's not being used. To do this, you would really just stream your Minecraft server logs into CloudWatch, then set up an alarm to check active users, and shut down the server after a certain period of time of no activity. This could save a ton of money if your server is only running for a few hours each day opposed to 24/7, and combine this with the spot pricing and you can really have this server running for next to nothing. Looking back at AMI, you can actually use this to track ongoing changes to the server. So, for example, you install a new mod and something breaks, you could easily just roll back to the previously working AMI configuration. Auto-scaling groups you could also look at. This would allow you to set up your service across multiple servers so you can ensure it's always up and running. This, of course, if you aren't looking at the spot pricing model. Reserved instances, also a great way of saving money if you know the service is going to be in use for a while. For example, you could pay for up to a year ahead of time and receive a pretty decent discount on the overall cost versus paying month by month. Back on CloudWatch, another thing you could do is set up a change management log. So if you have, say, multiple people working on the server, for example, everything that's done to it could easily be tracked. Finally, another thing we actually do on our Community S3 site as well is using DynamoDB, you can write and display a list of active users at any given time, so people on the website could easily see who's online and playing at the moment. So these are just some more ideas to get you started playing with your new server environment in AWS. The sky is really the limit when it comes to customizing your own setup. Well, hopefully today you got some new understanding of just a few of the services AWS has on offer. If you have any questions or comments for us about today, please leave it below or feel free to send us an email anytime to hello@exampro.co. Thanks for watching.